Boom.
Good morning, ladies and gentlemen. Let's go ahead and start our review. What does each variable stand for?
Verpy.
Oh yeah, it says burpee.
Verpy.
I was like, burpee. Can you do this? We've got the electrical potential difference, we've got the current, resistance, power, and electric field.
Yep.
Good, feeling good?
Okay.
Now, what are the units for each?
Pause the video. Think about it.
Did you get volts, amps, ohms, watts, and newtons per coulomb?
Yep.
If you did, we're starting in a good spot. If you didn't, make some changes. A kilowatt hour must have power in kilowatts and time in hours.
Yeah, this is for electrical energy. And what we've been doing is if you use joule seconds, you get these huge numbers, which would, when they're charging you for electrical energy, which would make your parents suffer.
Scientific notation, we don't want that.
Yeah.
So these units help make it easier for your parents to look at the
And it's
number.
also easier to work problems out.
Yes.
All you got to do is make the conversion from watts to kilowatts and use the hours you're given.
What does the 1.5 volt battery do to the 0.145 amps of charge flowing through it? Well, there's two options here. Does it increase or does it decrease the energy? Well, the battery is going to increase the current flowing through it. Okay, so it increases the energy.
Yep.
Okay, and how about the bulb? What is the bulb doing to that current as it flows through it? Well, it's going to decrease the energy.
Yeah, and what's happening with the battery is it increases the electrical energy of the charge, and it gets that from chemical energy.
Yes.
And here it decreases the electrical energy of the charge flowing through the bulb because it's being converted from heat into heat and light.
Yeah, and we did not go over the chemical equation with them.
They don't need it.
Yeah. So there is a chemical reaction that goes on in the battery. That's why you get that white stuff on the outside of your battery sometimes,
Yep.
right?
When they're old and don't work anymore.
Yeah,
They've been in the drawer for a year.
It's because there's a chemical reaction going on in there that goes sour sometimes.
That's
okay.
right.
All right, so would a higher resistance bulb let more or less current flow through it?
What does resistance mean?
I was like trying to push through, trying to get through, right?
Yeah.
Okay, so if I have a higher resistance bulb, there is going to be less current flowing through it. Less current means that we have not as much power, or it's going to be more dim.
Right.
Right? Think about that P equals I times V equation.
Yeah.
Okay, moving on here. Conventional current assumes that assumes that positive charge carriers are moving in the wires, not electrons.
Yeah, and this is a holdover from a time before our species knew anything about electrons.
When dinosaurs ruled the earth. No, not that far ago. Okay. And then that's it. So lastly, for review, you guys are going to do number 12 on page 517, 17A and B on 522, and then on page 525, number 19.
You should be able to do these at this point. This is the kind of stuff that's going to be on the quiz. And if you can't do it now, then you got to figure out why not and how you can fix that, okay?
Talk to me. Ask me questions. Okay, bye.